Alright, so now we can go over some of these nomenclature practice problems. And we start out pretty simply with this first one. We should see that this longest chain goes straight down the middle. And we can number it in either direction, but we see pretty quickly that we're going to want to start this one from the left. Starting it from the left gives us our first substituent at 2, whereas starting it from the right gives us our first substituent at 3. And so overall we have this as a heptane because it's 7 carbons. There's 3 substituents at 2, 3, and 5. And all of them are methyls. So we can combine those. And the name here is 2,3,5 trimethyl heptane. Alright, our second example, we've got to look in a different direction for the longest chain. It actually goes top to bottom. Now, unlike many others, this one becomes really easy to determine direction. Because if we start at the top, our very first carbon has a substituent on it. If we start at the bottom, though, our first carbon, this one here, doesn't have any substituents on it. So we know we have to start at the top, and then we come down. So with 8 carbons, we know that this is an octane. We can start naming the substituents. At 1, we have a bromine, or bromo. At 1, we also have a chlorine, which gets named as chloro. And then we have a bunch of methyl groups. In fact, we have 4 of them. 4, 4, 5, and 7 are all methyl groups. So all we need to do at this is alphabetize. 1 bromo, 1 chloro, 4, 4, 5, 7, tetramethyl octane. All right, how about part C? Again, I think we can see fairly easily that our longest chain goes right down the center of our drawing. But here, determining direction is going to be a little bit more difficult. So we're going to write out all the numbers. So going left to right, I'm doing it in gray. This also shows that we have 10 carbons here. We're dealing with decane. But in gray, we have substituents 2, 3, 4, 6, 7, 8, and 9. We'll go red for the other direction. And our numbers here are 2, 3, 4, 5, 7, 8, 9. So we can see our first substituent, either direction, same number. Second substituent, same. Third substituent, same. It's not until we get to the fourth substituent that we end up with a difference. And we can see that the red number is lower than the gray number. And so we come with this as our first carbon and work right to left. So what are the substituents here? Well, 2, 3, 5, 7, 8, and 9 are all methyls. What do we have at 7? At 7, we have a 4-carbon substituent, so we're dealing with butyl, but it's not connected at the end. It's connected on the second carbon. So this 7 is sec-butyl. So now we're ready to write out the name. I'm sorry, that's not 7, that's 4. We're ready to write out the name. What comes first alphabetically? Is it methyl or is it sec-butyl? So sec or secondary is a numerical term. So it gets ignored for alphabetizing. So sec-butyl gets alphabetized under B. So this compound is 4 sec-butyl, 2, 3, 5, 7, 8, 9 hexamethyl decane. All right, part D, our longest chain is going to be 9 carbons and go straight down the center. Now you might be wondering, instead of going that way, why didn't I come up this way? Because that's also 9 carbons. But if you count the number of substituents, we'll end up with less substituents going in that direction. And since they're both 9 carbons, we want to go with the one that has more substituents. In terms of direction, if we start on the left side, our first substituent is on carbon 3. But if we start on the right side, our first substituent, the fluorine, is on carbon 2. So we'll go from right to left. We'll list our substituents. Carbon 2 is a fluorine. 4 is an ethyl. 5 is an isobutyl. 6 is propyl. And 7 is chloro. The parent chain here is 9 carbons, or nonane. So when we alphabetize these, and we need to determine this right away, where does isobutyl get alphabetized? Is it under I for iso or B for butyl? Because remember, in the previous example, when we had sec-butyl, we ignored the sec for alphabetizing. But there's a big difference here, and that's iso is not a numerical prefix. And so isobutyl gets alphabetized under I, not under B. So we can alphabetize these. 7 chloro, 4 ethyl, 2 fluoro, 5 isobutyl, 6 propyl nonane. Alright, we have one more to do. This is one of those ones that looks really awful until you actually get into it, and then you realize it's not that bad. So our longest chain here we can see comes right down the middle. Now, unlike every other example we've talked about, it doesn't matter which direction we number this one in. Why not? Well, let's see. If we go left to right, or if we go right to left, we see that this molecule is completely symmetric. So it doesn't matter which direction we go in. What substituents do we have? Well, at 4, we have a tert-butyl, and then we have a whole bunch of methyls. So let's go ahead and write out the name, and as we're doing that, we'll determine where the methyls are. So tert-butyl, B, comes before methyl. We get 4 tert-butyl. So methyls, we have 2 of them at carbon 2, 2 at 3, 2 of them at carbon 5, and 2 of them at carbon 6. So there's a total of 8. Prefix for 8 is octa, so this is octamethyl, and then for the parent chain, heptane.